First of all, I'll give some idea about the tudes that I provide within the first unit. So there will be 10 tudes: theory book 1, theory book 2, and theory book 3. The past paper book, workbook 1, workbook 2, and school and provincial paper book, the practical book, time management book, and finally the short note. So I'll show you the tudes that I have provided up to now for our 2027 class during our first unit. So this is the first theory book. So it has the part of first unit theory in detail. So you can go through this one and you can get some deep idea about the first unit that you are going to learn for your chemistry as a first unit, right? And this is the school and provincial paper book. So I have prepared a few papers by getting the question in school and provincial papers, and that is there. And this is the past paper book. So here we have past papers, and for the unit 1, so you will be getting 25 MCQs for your first term test. Here also I have arranged in that way past paper questions, nearly 45 years of past paper MCQs is there, like papers. And this workbook 1, so it has structured essay questions regarding unit 1. And these are time management book. So in this one, so I have included all the syllabus and the structure of the paper and the theory, how we are going to learn during our chemistry class. And here some track records you can put, and also you can include some data regarding that what we are doing during your days. And also you can keep some track record, how you practice, how you learn questions and theory, all the things. And also finally here we can create some timetables as how you are going to plan your work. So there is this tude for that one. Not only that, so we have given those things up to now, and also we have conduct 2 practical sessions, and this is the practical quiz 1 for the first practical session, and this is the practical quiz 2 for the second practical session. So we have completed those things up to now, and I'll be giving the other tudes during the next few days of the first unit, right? So those are the basic idea about the material that I am giving during the first unit. Okay, let's start the first unit, atomic structure. Here I have given the conceptual structure of the universe. The big guy is multiverse. It is a collection of multiple universes, and then it comes to the universe, our known cosmos, including all of space-time, matter, and energy. And then comes to the galaxy clusters, and then galaxies like Milky Way, and then solar systems, planets, living beings, and molecules, atoms. Small one is subatomic particles. Not only that, quantum fields, and also finally the smallest thing is strings, string theory. Right, those are the things. So when we learn atomic structure, so we do not learn about these things, and we go to the smaller things, not the living beings, right? So we go to the place where there is molecules, and where there is atoms, and where there is subatomic particles. And we do not go to the quantum fields, we do not go to the string theory, and also we do not learn about the multiverse, universe, galaxies, like solar systems, or all the other things. So what we learn here, so what we are going to do here, we are going to get some idea about molecules, atoms, and subatomic particles. So this is our scale. So you can imagine what are we going to learn and what is the size of those things, right? So it is the range here: molecules, atoms, and subatomic particles. So that is the basic idea. So by keeping that idea, let's move to the next part. Let's move to the next part, right? So there are next few things. What is chemistry? And Empedocles, Democritus, and the Dalton's atomic theory, and the evidence that proves the relationship between matter and electricity. So those are the next few things that we are going to discuss. So regarding what is chemistry, so I have included all the things into the first theory book. And regarding the things that Empedocles says, so all the things I have included here, and also about the Democritus and Dalton's atomic theory, that is called golf ball model. So I have included those things here. Those are like past things, history of chemistry, and those things will not ask him for A-level paper. Now that is in different place. We are not going to check for the history. So that is there. And we are going to start from here. Evidence that proves the relationship between matter and electricity. Basically, we have to learn regarding three things. One is static electricity, the other one is electrochemical cells, the other one is electrolysis. The static electricity. So so nowadays we learn grade 9 about static electricity. When there is lightning, we can observe the how much strength is there for the static electricity. And also we have to learn again electrochemical cells and the electrolysis for the unit 13. For the unit 13, electrochemical cells and electrolysis, we have to learn for the unit 13, right? So those are the basic factors regarding these things, right? So all the things are there in the theory note, and it is not needed to go through each of the point regarding these things. I will be doing that one during the physical class when we do the theory book 1, when we do the when we do the theory book 1. So therefore we will move to the next part, right? We will move to the next part. The static electricity gives some relationship how we can pass currents through solids, and electrochemical cells and electrolysis give some idea how we can pass current through liquids. And earlier scientists done research to find out how we can pass current through gases. So Parker, Hitop and Crookes, they have conduct some research to find out how we can pass current through gases. Crookes developed a tube which is called Crookes tube to do research to find out how we can pass current through gases, right? And then so we have to move to the discovery of subatomic particles. So now we know what are the subatomic particles. Electrons, protons and neutrons are the three basic subatomic particles that we have to learn, right? We know that one. So discovery of electrons. So electrons discovered by J.J. Thomson using cathode ray experiment. And let's see how J.J. Thomson discovered electrons using cathode ray experiment, and that is what we have to look at. Let's move to the cathode ray experiment. J.J. Thomson conduct a series of experiments to identify the properties of cathode rays. So he used Crookes tube to conduct the experiments. The experiment conduct using Crookes tube is called cathode ray experiments. So the person who done these experiment is J.J. Thomson. Let's try to identify the theory behind the cathode ray tube. So normally air does not conduct electricity, but when we apply a high voltage like 10 kilovolts to 20 kilovolts at low temperature, the air become conductive and it will conduct currents. So when air conduct currents at high voltage and low pressure, air can conduct currents. So J.J. Thomson used Crookes tube. So what is in the Crookes tube? There are two electrodes. One is called cathode, the other one is called anode. So cathode is the electrode which connected to negative plate of the electric supply, and the anode is electrode which is connected to positive terminal of the electric supply. And there is also a vacuum pump. We can use vacuum pump to reduce the pressure inside the tube. So when the voltage increase and while the pressure decrease, J.J. Thomson observed a certain rays start emitting starting from the surface of the cathode and they travel towards the anode. When we applied a fluorescence material like zinc sulfide, so when these rays hit on the surface which zinc sulfide plated, they give greenish glow. Right. So those were the observations. Right. Those were the initial observations. So certain type of rays start emitting from the surface of the cathode and they travel towards the anode. When we apply a fluorescence material like zinc sulfide, they give greenish glow. That is it. Right. And then J.J. Thomson conduct several experiments to identify the properties of cathode rays. And here we have to learn few basic properties of cathode rays. So here I have indicated them. The negatively charged, cathode rays are negatively charged. Cathode ray has a charge. Cathode ray travel in straight lines. And cathode ray emit perpendicular to the cathode. And cathode ray possess momentum and energy. And also we have to learn about the E over m value of the cathode ray. It means the charge over mass value of the cathode ray, and that is a constant. And there are several properties of the cathode rays, right? So all the other properties I have included into the theory notes, and here let's go through each of these properties and what are the experiments that J.J. Thomson conduct to identify each of these properties. Let's move to that part. Let's look at the properties of the cathode rays. Cathode rays are negatively charged. Here what we can do? So what we can do is we can apply an external electric field. So when we apply an external electric field, cathode rays will attract towards the positive plate. If something attracts positive plate, means it should need to contain a negative charge. Since cathode rays attract positive plate, means cathode ray contain negative charge. That is it. So when we go to the next one, cathode ray has a charge. So we can apply external magnetic field. So what we can observe is the cathode rays will bend perpendicular to the external magnetic field. Right? So we know the charged particle will bend perpendicular to the magnetic field, the direction of the magnetic field. Right? So therefore we can predict that the cathode ray should need to contain a charge. And also by checking the direction which cathode rays bend, the cathode rays bend perpendicular to the magnetic field in the direction which negatively charged particle bend. In that case we can also predict cathode ray contains negative charge. If we move to the next one, the cathode rays travel in a straight line. So what we can do here is we apply an object in the middle of the cathode and the anode. So observation will be a sharp edge image, right? Image with sharp edges we can observe. So from that observation we can say that cathode rays travel in a straight line. The next one, the cathode ray emitted perpendicular to the cathode surface. To prove this one, we use concave cathode. So when we use a concave cathode, we can observe that the cathode rays will focus on a point. From that we can say the cathode ray emitted perpendicular to the cathode surface. So that is it. And then let's move to the fifth one, the fifth property of the cathode rays. Fifth one, the cathode ray possess momentum and energy. To prove this one, we apply a paddle wheel in the middle of the cathode and the anode. So when we put a paddle wheel in the middle of the cathode and the anode, our observation will be the paddle wheel will start moving. Paddle wheel will start moving. So if paddle wheel start moving, we can say that the cathode ray should need to contain a mass also. Since cathode rays travels cathodes to anode, we know that cathode ray contain a velocity. Cathode ray contain a velocity, right? It contain a velocity. Since cathode, because of the cathode rays, this paddle wheel start moving, it means cathode ray can do a work. Cathode ray can do a work. It means cathode ray should need to contain a mass. It should need to contain a mass. It means cathode ray should need to contain a momentum L. The momentum is equal mass multiplied by volume. Mass multiplied by volume. So from this we can predict that cathode ray possess momentum and energy. It possesses momentum and energy, right? So that is it about that one. And let's move to the constant E over M. Cathode ray has a constant E over M value, charge over M value, E over M value, right? So here E mean charge, M mean mass, charge over mass. The charge over mass of cathode ray will always be a constant value, and that value is 1.75 10 to the power 11 coulomb per kilogram. So this value is a constant. This value is a constant. So how we determine the value of the cathode rays? How we determine the value of the cathode rays? So before going to that one, we need to know from where cathode rays start, from where cathode ray originate. We need to know that one, from where cathode ray originate. To find that one, so what we can do is, we can change these electrodes, and we can check E over M value of the cathode rays. So what we can do, we can change the electrodes, we can change the metal that we use for the electrodes, cathode and the anode, and we can observe calculate the E over M value. So E over M value was found by the J.J. Thomson. He was the person who has conduct all of these experiments, and finally he also found the E over M value, that is 1.75 10 to the power 11 coulomb per kilogram, and that is a constant. So J.J. Thomson was found that, and also it was a past paper questions. In that past paper questions, it asked who was the person who found the E over M value. So we have to remember this one. So again, when it comes to where the finding of the where cathode ray originates, we change the cathode and the anode, and we measure the E over M value. So no matter what type of cathode or anode we use, always E over M value, that will be a constant. So from that observation, what we can say that the cathode rays do not depend on the type of the cathode and the anode. So you can write the properties of the cathode rays do not depend on the type of the cathode or the type of the anode. It do not depend on the type of the cathode or the type of the anode. So we do not need to discuss about the anode, because since we know the cathode rays start from the cathode, so no need to discuss about the anode. So when we change the metal of the cathode, the properties of the cathode rays do not change. So what we can tell from that one, cathode rays are common for all the materials. Right? And next one, even when we change the gas inside the tube, when we change the gas inside the tube, it means we can use O2, N2, argon, or any kind of a gas. We can use helium likewise. No matter the what type of gas we used inside this cathode ray tube, E over M value does not change, or any of the properties of the cathode ray does not change. It means, so we can say that the cathode ray is independent from the gas inside the tube. Cathode ray is independent from the gas inside the tube. So what we know now, when we change the metal of the cathode, the properties E over M value does not change. When we change the gas inside the tube, E over M value does not change, right? So therefore, the Thomson predict that the cathode rays are kind of fundamental particles for all the materials, for all the matters. The cathode rays are fundamental particles for all the matter. Cathode rays are fundamental particle for all the matter. He predict that, right? And he calculated E over M value of the cathode ray as 1.75 10 to the power 11 coulomb per kilogram. So those are the basic things regarding the cathode rays, and I have given many more properties and the things regarding the cathode rays in the first theory book, so you can refer that one. And also I will be doing this one next month, right? So in our theory class there will be 3 types of theory, right? One is the thing that I have normally what we are writing. The second one is the theory book, in detail theory book. The third one is short note, right? I'll be doing 3 times. The middle part, the middle depth, we will be doing in the class. In depth also I will be giving a note and I'll be discuss that one in the class again, and also we will be writing a short note, right? So let's move to the next part of the cathode ray, right? Next thing is the charge of an electron. The charge of an electron was measured by Robert Millikan through the oil drop experiment. So I have put the experiment how he determined the charge of an electron to your theory book, so you can refer that one. The charge of an electron is 1.602 10 to the power minus 19 coulomb. So after we find the charge of an electron, we can calculate the mass of an electron. To calculate the mass of an electron, we need E over M value, which was found by the J.J. Thomson, 1.76 10 to the power 11 coulomb per kilogram, and the charge of an electron, which was determined by the J.J. Thomson. So here we can write the equation E over M is equal E over M, and we subject M, so that is equal E over M. So here we will do the calculation. Charge value is 1.602 10 to the power minus 19 coulomb, and then 1.76 10 to the power 11 coulomb per kilogram. We can simplify this one. 9.1 10 to the power minus 31 kilogram. So that is the mass of an electron. 9.1 10 to the power minus 31 kilogram. So that is the thing about the charge of an electron and the mass of an electron. Next subatomic particle is proton. So to get an idea about the protons, we have to go to the discovery of the canal rays. Now we are working with the Crookes tube, and one of the scientists who called the name is Eugene Goldstein. He also worked with the Crookes tube, and he conduct some experiments. So when he used a cathode with holes, he could observe that there is something new type of rays go through the holes of the cathode that he used. When they hit on the surface of the tube, right, it give red color glow when we applied a fluorescent material like zinc sulfide, right? So what he observed is a new type of ray is go through the holes of the cathode, right? Holes of the cathode, and the direction of that new type of ray is opposite to the direction of the cathode rays. Now we know cathode ray originate from the cathode, and they originate from the surface of the cathode, and cathode rays go towards the anode. Cathode ray go towards the anode, and something new is go to the opposite direction of the cathode rays, and those rays go through the holes of the cathode. When they collide on the surface of the wall, which plated with the zinc sulfide or fluorescent material, it gives red color glow. So that is what he observed. So we have to look at the properties of these new type of rays. So since these rays originate from the gas inside the tube, right, they put the name as canal rays, right. Now we are going to check the properties of these canal rays. So to get an idea about the properties of the canal rays, we have to do certain experiments that what we conducted for the cathode rays, right. So here these are some properties of the canal rays. They originate from the gas inside the tube. They originate from the gas inside the tube, not the anode, not the cathode. They originate from the gas inside the tube, right. They travel in straight lines. They travel in straight lines. So here also we can use the same experiment that we used to use for the cathode rays, and this one, they has a positive charge. So what we can do is we can apply an external electric field. So when we apply an external electric field, this new type of rays will attract towards the negative plate. So they has a it has a positive charge. It has a positive charge. So when we apply a magnetic field, they also deflect by magnetic field. They deflect perpendicular to the magnetic field, and that direction is totally opposite to the direction of the cathode rays. And when it comes to the E over M value, it means charge over mass ratio is not a constant value. It is not a constant value. It means when we change the gas inside the tube, E over M value changes. When we change the gas inside the tube, E over M value changes. So to get an idea about this one, we have to look at how these new type of rays produce. Right? If we think we get H2 molecule, right? We get H2 molecule. So H2 molecule has a single bond. When these cathode rays collide with those bonds, the bond will break. Right? Bond will break. If we go to the electrons, there are two electrons. When cathode rays also electrons. When electrons collide, the bonding electrons will break, and they will go back where they comes. The electrons go to this hydrogen, and one of the electron go to here, the other electron go to here, and they will form atomic hydrogen. So after they form atomic hydrogen, further collision with the cathode rays, these electrons will remove from the hydrogen atoms. The electrons will remove. In that case, they will produce H plus ions. So if we get this one, at the first stage, what happens? H plus two hydrogen atoms will form. And further collision, these two hydrogen atoms will remove two electrons by forming 2H plus ion. So that is what happens. If we get another example, like Cl2, it will form Cl atoms, and further collision, it will form Cl plus Cl plus ions plus 2 electrons. Right? Now these plus charges, hydrogen and Cl plus likewise, they form plus charges. Since those are plus charges, they will attract towards the cathode. They will attract towards the cathode, and the direction will be opposite to the direction of the cathode rays. Since Goldstein used the perforated cathode, it means a cathode with holes. Those canal rays go through the holes of the cathode. So that is what happens. So this is how the canal rays produce. Since these canal rays are positively charged, they also call positive rays. They also call positive rays. And most of the time these canal rays produce near to the anode. Therefore, they also name as anode rays. That is mentioned in your resource book. So these three names used for same thing: canal rays, positive rays, and anode rays. And this is how it produces. And here these are the properties. So if we go back to here, and E over M ratio is not a constant. It changes. So that it gets some idea about how it happens, right? Here, even though charge is plus, here also charge is plus, but the mass is different. Mass is different. We know hydrogen has light mass and the Cl has more mass than hydrogen, H pluses, right? Therefore, when the charge remains constant but the mass changes when we change the gas. When we change the gas, right, the mass changes. Therefore, E over M value changes. The atom which has smaller mass has higher E over M value because E is most of the time. So let's consider the plus one as the charge. When the mass increases, E over M value decreases. So lightest ion is H plus ion. So H plus ion should need to have the highest E over M value. H plus is the ion which has highest E over M value. That is the highest E over M value. And also when it comes to H pluses, right, E over M value of H plus, right, the mass is also, if we consider the relative mass, that is 1, charge is 1, relative mass is 1, right? E over M value is, again if we get the relative values, so let's think that is 1. So what happens if we use Cl or the other ones? The mass will become bigger, right? This value will become bigger. So when we multiply the E over M value of the other particles, if we multiply by certain integers, we obtain the E over M value of H plus. Right? In that case, they predict that the H pluses are common for all the matter. And then with that one, we can move to the discovery of the protons. Right? The smallest positive ion observed was H plus. That is H plus. And that was, they could observe that was the value E over M value is common for all the particles, right? It means the other E over M value multiplied by certain integer value, it gives us the value of the H plus, right? And then Rutherford identified, right, discovery of the proton. Rutherford is the person who identified that one from the one of his experiment. So that also I have included into the theory note. And Rutherford is the person who named the proton. Is the person who named the protons, right? So that is about proton, and let's discuss the charge and all the things about protons and also the other subatomic particles, right? Then we have to learn about the neutron, that is also one of the subatomic particle. James Chadwick is the person who discovered the neutron from one of his experiments. That is it about the neutrons, and we have to know the charge and the mass and all the things regarding the neutrons. And you also know, the mass is greater than the mass of proton, and there is no charge for the neutrons. And also why is the neutrons more important? So, and also those kind of thing I have included into the book, so you can refer it, right? Then let's move to the next part, right? Before moving to the next part, so let's go through some summary regarding the subatomic particles. electrons, protons and neutrons. So these how we symbolize them. Minus 1, 0, E minus 1, 0, proton P 1, 1, neutron 0, 1. So that is how we symbolize them. And when it comes to the relative charge of the electron, that is minus 1. Proton relative charge is plus 1. The neutron, there is no charge neutron, that is 0. An actual charge, we know the minus 1.602 10 to the power minus 19 coulomb. And the actual charge of the proton is plus 1.602 10 to the power minus 19 coulomb. And neutron, no charge neutron, that is 0. Relative mass, the relative mass of electron is 1 over 1840. And here the relative mass of proton is 1. The relative mass of neutron is also 1. When it comes to the actual mass, here the 9.11 10 to the power minus 9 minus 31 kilogram, and is 1.672 10 to the power minus 27 kilogram. Here mass is a little bit higher than the mass of proton, 1.675 10 to the power minus 27 kilogram. Discovered by electron, discovered by J.J. Thomson. Proton discovered by Eugene Goldstein. Neutron discovered by James Chadwick. So that is the summary of the subatomic particles. Right. Next topic is radioactivity. Write down radioactivity. So let's see how radioactivity occurs. When the mass of the nucleus increases, the nucleus become unstable, or the atom become unstable. Because of that instability, right? Because of instability, the some elements emit rays because of that instability. This phenomenon is known as radioactivity. So that is what we call radioactivity. The such elements are called radioactive elements. Such elements are called radioactive elements. Discovered by Henry Becquerel. Discovered by Henry Becquerel. And Ernest Rutherford did further experiments regarding radioactivity, and he identified 3 types of new rays: alpha rays, beta rays and gamma rays. The Rutherford identified alpha rays, beta rays and gamma rays, right? So those are the basic factors regarding the radioactivity, and then we have to learn about the properties of alpha rays, properties of beta rays and the properties of gamma rays in the next part.